welcome to Virtual CB1A. This is Miss Rena, and today we will have another discussion in the subject Mathematics, Science, and Technology. We're going to talk about measurements in science, large quantities and small quantities, the scientific notation. We will start with the learning objectives. At the end of this lesson, you are expected to understand the idea and usage of scientific notation and solve problems in scientific notation. So when do we use scientific notation? It is used to represent extremely large or extremely small quantities we often encounter in science. Let's look at some examples of extremely large and extremely small quantities. The approximated distance between the Earth and the Sun. It is approximately 149,600,000 kilometers or 92,900,000 miles. For the world population, it is already estimated to be about 7 billion. And then the number of cells in the human body is approximately, there you have it, I won't read it for you. Let's go to extremely small quantities. First, the mass of a dust particle. It is 0.00000000753 kilograms. And for the mass of an electron, it is really difficult to read this one, so I won't read it for you. Just look at the value. There are a lot of zeros before our digits 91093822 kilograms. So it is really confusing if you will have to compute numbers such as this. That's why we have scientific notations. Scientific notation is a shorthand way of writing such numbers. A number is in scientific notation if it is expressed in the form of a times 10 raised to the nth power, where a and n is an integer. You have to take note of this. If n is positive, we have a relatively big number. And if n is negative, we have a relatively small number. A number between 1 and 10 multiplied by 10 raised to some exponents. Let's look at this example. We have a number in scientific notation. We have 5.75 times 10 raised to 4. We are going to transform it into its decimal form. Since the power is positive, we expect a relatively large number. So this expression can be written as 5.75 times 10 times 10 times 10 times 10, using your knowledge on exponents. Furthermore, it'll be equal to about 57,500. Okay? So how do we write numbers or relatively large numbers in standard scientific notation? Okay, let's reverse the example. From this number here, 57,500, we are going to write it in scientific notation, 5.75 times 10 raised to 4. So how do we do that? These are the steps that we are going to follow. Writing scientific notation in the form a times 10 raised to n. You have to move the decimal point to get a value greater than or equal to 1, but less than 10. This value is a. So the number of times that you are going to move your decimal point is really important. Count the number of places you moved decimal places. If the decimal point is moved to the left, the power n is positive. If the decimal point is moved to the right, the power n is negative. So please do not be confused. I know that we often associate left with negative and right with positive. But in case of scientific notation, if you are going to write something in decimal form, to scientific notation, you have to take note that when you move to the left, the exponent is positive. And when you move to the right, the exponent is negative. Let's have step 3. Write your answer in the form a times 10 raised to n, where a is greater than or equal to 1 but less than 10. So take note, a should be between 1 and 10. It can be equal to 1, but it cannot be equal to 10. It is always less than 10. Next, I didn't finish the last sentence, so I will just write it in this video. Drop the non-significant zeros. Okay, so as I've mentioned earlier, we are going to write the number 57,500 in scientific notation. So it is in decimals. It is a relatively large number. So we expect a power that is positive. Let's see. So since 57,500 is a whole number, let's locate its decimal point. Its decimal point is in the end. So it is after the last digit 0. Now let's move the decimal place 4 units to the left to make our A greater than 1 but less than 10, or between the value 10. So to do that, let's move the decimal place 1, 2, 3, 4. So it should be between the first and the second digit, 5 and 7. So you will end up with 5.7500. After that, let's write it in the form a times 10 raised to n. You have to take note that for non-significant zeros, so these two at the back, we can already drop them. Let's leave 5.75 as our a. And then, our exponent is the number of times that you moved your decimal point. Again, that is 1, 2, 3, 4. And since we moved to the left, the sign of our exponent is positive. To make it even clearer, let's compare it with this relatively small number. We have 0.000575. Let's write it in scientific notation. So this number is a decimal less than 1. We have to write it in the form such that a is between 1 and 10. So let's move our decimal point n units. 1, 2, 3, 4. So since 5.75 is already between 1 and 10, we have to move 4 decimal places. So we have 5.75, move the decimal place 4 units to the right, making it a decimal between 1 and 10. After that, let's write the exponent. It is the number of times that you move to the right. And the sign is negative since the movement is to the right. Okay? To make it even more clearer, let's go back to the extremely large quantities from our examples earlier. The approximated distance between Earth and the Sun. It is approximately equal to 149,600,000 kilometers. So let's represent this number in scientific notation. How many times are we going to move our decimal place, and on what direction? So I will just change the color of my pen. Just wait a moment. Let's use purple. The decimal point here is after the last digit 0, since that is a whole number. From here, we have to make the number greater than 1 but less than 10. So let's move our decimal point. 1, 2, 3, 4, 5, 6, 7, 8. We have to move 8 decimal places to come up with 1.496. And then the remaining zeros will be dropped since they are not significant. Now let's affix times 10. We have to look for the exponent. So what is the exponent? It is the number of times that you moved your decimal place. Let's count it again. 1, 2, 3, 4, 5, 6, 7, 8. So the exponent is 8. What will be the sign of the exponent? Since you moved to the left, the sign should be positive. Okay? I hope that was clear. Let's have another example. The approximated distance between Earth and the Sun pa rin, but in miles naman. Oops, I can't find my pen. And if there are units of measurements affixed with your given value, please write the unit of measurement. Since this is represented as kilometers, you have to affix the letters K and M, in short for kilometers. Let's go to the next example, miles. Again, this is an extremely large quantity. It is a whole number. The decimal point is after the last digit 0. Let's move the decimal place so that we can get a value that is between 1 and 10. 1, 2, 3, 4, 5, 6, 7. We moved 7 decimal places. So let's write it as, I hope it is still visible. We have 9.29 times 10 raised to 7. So we counted earlier that the number of movements is 7. What will be the sign? Since we moved our decimal place or decimal point to the left, the sign is positive. And then, of course, since it is in the unit miles, let's write here miles. Let's have another example. The estimated world population. For the estimated world population, we are now about 7 billion. Ang dami na natin. Again, this is a whole number. The decimal point is at the end of the last digit 0. Move the decimal point and units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ayan. We have to move 9 units. So we have here 7 times 10 raised to the 9th power. That's it. Since wala namang unit, tigil na tayo dyan. Or yung ibang students, if you come up with 7.0 times 10 raised to 9, this is also correct. But I dropped it since, 0 is not significant and this is represented in whole numbers naman. Let's go to the next example, the approximated number of cells in the human body. Kakapagod siyang tingnan. So how many times are we going to move our decimal place to the left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have to move our decimal place 14 units to the left. Or, again, if you come up with 1.0 times 10 raised to the 14th power, that is also correct. Later on, we are going to talk about precision. I think we are going to talk about precision next week. So you will have an idea on how many decimal places you are going to use in certain problems. Now let's go to extremely small quantities. Mass of a dust particle. It is given by this number. So let's make A greater than 1 but less than 10. So let's move our decimal place and units to the right. This is our decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we moved 10 decimal places. We have 7.53 now. Times 10, of course. What will be our exponent? How many times did we move our decimal point? We moved it 10 units. Ulit nga. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tama, 10. Now, what will be the sign? Since our movement is to the right, the sign should be negative. Okay? Ito na yung mas nakakapagod. Oh my God. Ayan siya. So, how can we represent this in scientific notation? Let's count. We are going to move our decimal point here and units to the right. It should be between 9 and 1 to make our A between 1 and 10. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Yan. Nakakapagod. We have 9.109382 times 10 raised to 31. But you have to take note that the movements of our decimal point is to the right. So our sign here should be negative. Okay? Nakakapagod mag-transform into scientific notation, pero mas nakakapagod mag-perform ng computation if you are going to deal with numbers such as this, yung mga naka-decimal lang siya, hindi siya naka-scientific notation. Mamili kayo, anong gusto yung gamitin? Yung ganito o yung scientific notation? Baka tapos na yung midterm natin, hindi pa kayo tapos mag-solve. So please, learn how to transform decimals into scientific notation. It will be very helpful. So that will be it for our discussion on small quantities and large quantities, the scientific notation. Next time, we are going to talk about operations on scientific notation. Okay? So thank you for staying with me for about 20 minutes and see you next time. Bye!